Hey, pre-calc, we are going to start with 8.1, getting into the logarithm. And just so you know, you could probably figure this out all on your own. And because these are all true statements, don't get me wrong. But what the investigation is supposed to get you to realize, especially when they read it out loud as log base b of a, and you want to rewrite it as some sort of exponential, it's log base 3 of 27 equals 3. Well, if you want to make this an exponential function, this 3 would be your base, and it makes sense then that to the third power would give you an answer of 27. Just looking at the very next one right here, if 10 is the base, well, is it 10 to the 1,000 power that gives me 3? No, it's 10 to the third power that gives me, I think I said 10,000, I meant to say 1,000. So again, it's read log base 2. So 2 is the base of an exponent. Is it true that, well, it's 2 to the fourth power is giving me 16? And we just had the unit on exponents. So I hope you recognize that if 36 is the base, it's to the 1/2 power is equal to 6. In case you've forgotten, because some people forget it immediately after taking a test, that to the 1/2 power means the square root. And I could work through all of these, and you should notice a pattern. 27 to the 2/3 power will give you 9. And I think what I'll do is just show you the answer key. So try some of these other ones as I pull up the answer key. That you should have something like this. Now, I probably should have gone through a little bit more work with this one. Let me go ahead and do a little bit more work with that one. But as you recognize the negative exponents, make a fraction, and 5 to the third power is 125. This is a kind of a unique situation, so I really like that one. This one sort of looks obvious, something equals itself. I'm trying to see if anything else is sort of unique. And what you should recognize, let me go back to that, and I'm going to talk briefly about this one, is that sometimes you'll hear a teacher, and you may have actually learned it this way, of kind of like a boot, where you have 36 to the 1/2 power will equal that number. At least my teacher called it a boot, so you know how sometimes you just repeat what your teacher said. That's kind of my situation. 27 to the 2/3 power gives me 9. The reason why I wanted to talk a little bit more about this one is because what you might want to recognize is that if you look at this quantity, the 4 times the cube root of 4, that's really 4 to the first times 4 to the 1/3 power. Well, if we're multiplying with the same base, remind yourself that you add the exponents. So maybe change 1 to be 3/3. 3/3 plus 1/3 is equal to 4/3. So kind of an ugly problem, but it is still true that 4 to the 4/3 power, if you make your boot, is equal to that argument, 4 cube root of 4. Because 4 times the cube root of 4 is equal to, I guess, everything I wrote up there. And by the way, you can check your work by using your calculator. And that's why there's a special highlighter on this one. Because if the base and the argument are the same, they'll cancel each other out and equal 1. One more thing that I tend to overlook, and I think I haven't overlooked it here, is that both values we examine must be positive. And we'll talk about that in a second. Now, I'm talking about the base and the argument A. Those both need to be positive. As you notice, the equals number can be a negative. Let's see, here's a negative. Here's a negative. So that is okay. So based off this, hopefully you can make a conjecture on how one would find the value of log base b of a. Sometimes what I'll do is I'll rewrite this as log base b of a equals x. or any variable you want. And therefore, here's your symbol for therefore, b to the x power is equal to a. This, if you make your boot out of that, is a true statement. So again, you're just asking yourself, b to what power would give you that number? There might be another way of saying it. So one of the ideas that you should recognize, you can go up to the top, and again, basically it's saying we're looking at log base b of a. Notice that sometimes I'll write this in cursive. That's kind of a habit of mine because my teacher wrote in cursive. You don't have to write this in cursive. So if these two numbers are exactly the same, well, what that means is that our answer will be 1. So you can try any value you want. It will equal 1. If earlier we did log base 5 of 5, you could do log base 9 of 9. Well, it's 9 to the first power will give me 9. Make that number 8. I'm just kind of giving you some different options. 8 to the first power will give you 8. All right? So in the next one, again, the b is the base, the a is the argument that we've been talking about. If the base is smaller than the argument, well, let's go back up to our several examples and find where the base is smaller than the argument. Okay, a bunch of my examples that I did. Well, this one, the base is larger, and we got a positive answer there. So you don't want to just say it's greater than 0. But if you notice, if the base is smaller than the argument, well, this base is bigger. Maybe what the threshold is, and you can examine some more of your problems, is that you'll get an answer that's bigger than 1. And I hope you realize that 1 is sort of the threshold we're looking at. Oh, wait. I think I said something backwards. But 1 is the threshold we're looking at because if the base is equal to a, if they're equal to each other, we get 1. So therefore, if the base is smaller than a, and again, feel free to try a few problems. Like I'm thinking that 6 and that 36. This one gives me an answer of 2 because 6 to the second power will give me 36. So that's helping me think about how we get an answer that's greater than 1. That's my greater than symbol, by the way. And then if the base is smaller than a, so that would be an example like log base 36 of 6. And we did that problem. It was 36 to the 1/2 power. And what we care about there is that the answer is smaller than 1. And it is, I think I need to be careful on how I say this as well. Yeah, because even a negative answer is still smaller than 1. So I'm looking at this example where 4 is smaller than, 4 is bigger than 1/16. So the base is bigger than the argument, and we get an answer that's smaller than 1. Okay, so let me write that down. That includes the negative answers. And again, A and B cannot be negative. A and B must be positive. But you can get negative answers at the end. All right. So as we move forward, just so you know, we have what is called the common logarithm. And we don't always write log base 10. And this is exactly what your calculator does. So if you find your calculator, I'll just pull mine up. You can see I've been playing around with the log already. If you just hit the log button, there's no base here. It's implied to be 10. So for instance, if I start with log of 10, this is really log base 10 of 10, so you should already know the answer. It's 1. So as we examine our calculator then, if I ask you to do log of 5, and you don't have to close the parenthesis, at least on mine, we get that answer 0.699. And that answer should make sense because if you look at the base is bigger than that argument, so we should get an answer that's smaller than 1. And I'll just write that kind of off to the side. That makes sense. Now this next one you should be able to do without a calculator. Do you know 10 to a certain power to give you 100? I hope you do. It's 2. Okay, so we can get an exact answer on that one. No need to use a calculator, but just to verify it's 2. And then the last one, which is kind of why I wanted to just use the calculator. Log of 115 is 2.061. But we can confirm that that makes sense because our base of 10 is smaller than the argument, so we should get an answer that's larger than 1. That's all I'm trying to get out of that, I guess, concept. So I'm kind of in a conundrum as I move forward to the next one because I realize that graphing calculators will give you the correct answer. Okay, so as we get to a few of these problems, I'm more along the lines of can you do this in your head? Do you understand the underlying themes? But then also, this is what's called the change of base formula that I want you to recognize. Change of base. Because if you notice, they just changed the base on you. So anyway, if you think of this problem the way I want you to think of it, it's asking yourself, well, 3 to what power will give me 81? And you can guess and check. 3 squared, okay, that's 9. 3 to the third, that's 27. But what you could also do is you could change 81 to be a base of 3. Well, 3 to the fourth power is 81. So it makes sense then, if the bases are the same, the exponents must be the same. So the answer to that one should be exactly 4. Well, let me show you a couple things. And again, I'm not showing you this to just have you cheat, but under the math tool, pretty far down, that's why I just hit the arrow up a few times, you can find the log base 3 of 81. I said that wrong. It will give you the correct answer. Now the other thing that you should learn in this class is that it's what's called the change of base formula, where you do log of the number, so 81, divided by log of the base number, 3. This will also always give you the correct answer. That's why it's called a formula, because it always works. So the change of base formula always works. You get 4. But again, I do want you to recognize that you can do this all in your head. You don't need to rely on a calculator. That's why I'm in a conundrum. I know some of you will use a calculator. 2 to the x power equals 1/8. And if you think about it, well, in order to get a fraction answer, you need a negative exponent. 2 times 2 times 2, that's 3 of them. So your answer should be exactly -3. So can you use your calculator? Yeah. It's a math tool. The A option down, log base 2, alpha x to make a fraction. There you go. Gives you the answer. You can also just do the change of base formula. Log of 1/8 divided by log of 2 gives you the answer, -3. Now, what I want you to think about is, does the answer make sense as well? Because if I were to think about, okay, well, this is just guessing and checking. Well, 2 to the first power is 2, so that's a bad answer. 2 squared, that's 4, also not very good. 2 cubed, that's 8. 2 to the fourth power is 16. Well, because 9 is trapped between 8 and 16, that's a 9 right there, kind of look like a G, my answer should be somewhere between 3 and 4. So you choose at this point how you want to use your calculator. But if you actually type it in, it makes sense now that my answer is 3.170. That's what I need you to understand out of this. Does this answer match? Does my answer make sense? So at this point, I'm going to jump to the answer key so I can move forward a little bit faster. Write down what you need to. Here's the answers. Go ahead and hit pause. And this formula is always true. This formula always works. So I'm about to run out of time, so I'll see you in the next video to explain the rest of this section.